Welcome to this video on confidence intervals for difference of means. By the end of this video, you should be able to determine whether the conditions are met for doing inference about a difference between two means and construct and interpret a confidence interval for a difference between two means. So we're talking about two different kinds of cookies, Chips Ahoy and Walmart Chippers. We want to know, is there a difference in the number of chocolate chip cookies in Chips Ahoy cookies versus the number of chocolate chip cookies in Walmart brand cookies? So what I did is I went ahead and did the experiment for us, and I sampled 28 chips of each. So I had 28 of the Chips Ahoy, and I had 28 chippers. Okay, so this means we're going to end up subtracting here the Chips Ahoy minus the chippers. So if we were doing our four-step process, we wouldn't want to mention the subtraction order in our process here. So for the Chips Ahoy, I had the average number of chips per cookie after looking at all 28 cookies was 21.56 with a standard deviation of 2.49. And then the Walmart Chippers, when I looked at all 28 cookies, I had an average chip amount of 18.22 chips per cookie with a standard deviation of 4.51 chips per cookie. So when I found my difference, it was 21.56 minus 18.22, where I got a mean difference of 3.34. Okay, so if we did this process many times, I did this once. If we did this many times, what's going to happen? What will our sampling distribution look like? So if we do this many times, the sampling distribution will be approximately normal. Okay. To find the center, what will our sampling distribution center around? So the mean of the sampling distribution would be the same as if we took the mean of each and subtracted them. Okay, so that's why we're able to do this, and we're going to say this is going to be our center of our sampling distribution. Now the spread, that's your standard deviation, would be the variance, which remember is the standard deviation squared, divided by the first sample size, plus the variance of the second sample divided by its sample size. But we are going to end up using the information from our sample. So while it looks the same, how we call it, we're not calling it standard deviation, we're calling it, remember, the standard error. And mathematically, it works the same, but instead of using the population standard deviation here for this variance, you use this sample standard deviation and square it, and then divide it by its sample size, plus the sample standard deviation, square it of the second, and divide it by its sample size. Now remember, we're always adding when we're finding the standard error or the standard deviation, even though we were subtracting over here. All right, so we know where our numbers are going to come from. Let's check our conditions. So for the random condition, we have two samples. We have samples of Chips Ahoy and we have samples of chippers. Those are independent of each other. Chips Ahoy are not in the chippers and chippers are not in the Chips Ahoy. So we want to say independent, because they do not overlap in any way, independent random samples okay. For our 10%, So I had 28 cookies from each, but we got to address them separately. So 28 is going to be less than or equal to 1/10 of all Chips Ahoy. And I also have to address the second sample, which was also sample size 28, is less than or equal to 1/10 of all chippers. Okay, and then for our normal, okay, so remember, there's three ways that this can happen. It can be that the population distribution is normal, we have a sufficiently large sample size, so we have a central limit theorem, or if you have the sample data, you look at the graph. So we go back and look. We already know our sample size isn't quite big enough, but in reading through here, it says, due to the factory processes, we can assume the population distributions of the number of chips are approximately normal and that the samples are random. Okay, so the population distributions are approximately normal, so that's what we want to say here, is our population distribution is approximately normal. All right, now to construct our 95% confidence interval here. Remember I told you that our sample sizes, they just happen to both be 28 in this case, but I want to make a special note here before we go on about these sample sizes. Okay, so I'm going to turn the paper sideways so we have a little bit of room to write. These sample sizes, if your sample sizes are different, you're going to use the smaller sample size to get your degrees of freedom. Okay, so if your sample sizes are different, you're going to use the smaller of the two to get your degrees of freedom. It's a more conservative number, and so statisticians like to have that more conservative value. So our degrees of freedom here is 27, and that is on the table because it goes up to 30 by ones until it starts skipping. Okay, so we have our degrees of freedom of 27. So remember, we're going to get a point estimate, and you add and subtracted that, the margin of error. So to find your point estimate, you're going to take your sample means and subtract them, and we did Chips Ahoy minus chippers, plus or minus your T star times your standard error, okay. So now we're going to plug these values in. We already did the subtraction up top and we got 3.34 plus or minus. Now we're having a 95% confidence interval with a degree of freedom of 27. So we're going to go to 95% and we're going to follow it up until we hit 27, which is 2.052. So that's our critical value. All right, and then we're going to fill in our standard error, 2.49 squared, divided by that sample size of 28, plus the standard deviation of the other, 4.51 squared, divided by that sample size. Right, when I put these into my calculator, I got my low number of 1.34 and the high number of 5.34. So We have our interval of plausible values. Remember, we subtracted Chips Ahoy minus Chippers, and we got all positive numbers. That's interesting. Does this give you evidence that there is a difference in the average number of chocolate chips in Chips Ahoy and Chippers cookies? It does, because all the plausible values are positive. So in this case, that means the Chips Ahoy has more chips than the Chippers. But we were just asking specifically if there's a difference. Okay. So we have convincing evidence of a difference in the average number of chocolate chips. Okay. So for this question, this isn't asking one way or the other. This could also be convincing evidence that Chips Ahoy has more chips than Chippers. So if you get a confidence interval that is plus plus, they're both positive numbers, that would be convincing evidence of a difference. This would be the first one's bigger than the second one. If we got minus minus, this is also convincing evidence because that just means the second one was bigger than the first one. If you get a negative and a plus, though, this is not convincing because 0 is a plausible value is really what that means. Zero is a plausible value. Okay, so when we said here all the plausible values are positive, that means 0 was not captured as a difference. Was not captured. All right, so it's still building off of what we've talked about before. In this one doesn't ask specifically who is better or who has more, but is there a suggestion that there's a difference? There is, because both ends of our interval were positive, so 0 was not a plausible value for the difference. All right, so let's flip this over and cover what we need to be sure to include in our 4-step process for a difference of means. So we want to be sure to address when we look at our conditions, that you make sure you address the random, and we need them to be independent random samples. Okay, you need to be sure to address your 10% and the normal. And you need to do this for both populations. So check these for both populations. Okay, so you have to have each of them checked. And then you'll have your state, where you're going to define your parameter. Which would be mu1 minus mu2. And then be sure to include subtraction order. Who is mu1 and who is mu2? And you can say it, I'm subtracting this minus this. So include subtraction order. Be sure you put your confidence level in there. Then we have our plan, which will have all of our conditions over here. In addition to that, your procedure name is a 2 sample. t-interval, because we're making a confidence interval, for mu1 minus mu2. And then, so you've got your procedure name, you've got your conditions, and then we have the do part. I need to see the plugged in formula, no naked numbers. We need to see any work. We need to see the answer. And let me just remind you here to use the smaller degree of freedom. Okay, so use your smaller degree of freedom. And then you'll have your conclude. And your conclude is the we are whatever percent confident statement. Make sure it's in context. Okay. Complete the check your understanding. Upload a photo of the front and the back of these notes that we just did, including the completed check your understanding, and to Canvas, and we'll go over it in class. Hope this was helpful. See you there.